Alright guys, welcome to this page of the notes, and again what we're going to do is we're going to begin to take a look at that second objective or learning target, which is some general trends in the graphs of polynomials. Now, I mentioned earlier, and I'll say it again, almost all of what we're about to cover is conceptual, all right? It's stuff that you guys are going to need to memorize, all right? There isn't any algebra that you're going to have to do to figure this stuff out, all right? You've got to sort of memorize these trends, or know what they are, so that when you look at the polynomial, you can just by looking at it know which trends your polynomial is going to fall into. For some of you, this is going to be fantastic. For some of you, it's going to require a little bit more work because it's math that you're not really used to, kind of that conceptual math where you don't have to do any algebra. But here we go, let's jump right into it. Again, these are going to be general rules or trends when it comes to graphing polynomials. The first one we're going to talk about is zeros. And guys, this comes as absolutely no surprise, or at least it shouldn't. Zeros of a polynomial, just like with quadratics. Right? We just got done with chapter 4, where we spent a lot of time finding the zeros of a quadratic. Where does it cross the x-axis? Guys, polynomials work the exact same way. The only difference is this. Polynomials can potentially cross the x-axis many, many more times than a quadratic, right? A quadratic at most, at the very most, can cross the x-axis twice. Polynomials can cross the x-axis, well, not an infinite number of times, right? Because a polynomial can't be infinite, but you could have hundreds, thousands of x-intercepts and it'd still be a polynomial. So, many, many more times. But still works the exact same way. It is a point at which the graph of the function intersects the x-axis. This is what we call a zero. Let me go ahead and highlight it for you. Intersects the x-axis is called a zero of the function. Now, a couple more things for you. And polynomial with an odd degree. Remember, we just looked at the beginning of this set of notes, these videos, at sort of refreshing on how you find the degree of a polynomial. That is going to be very, very important. You need to be able to find the degree of a polynomial because that is going to have a large effect on what the graph is going to look like. Just knowing the degree of the polynomial actually tells you a lot about the graph of the polynomial. The first thing we're going to look at is this. A polynomial function that has an odd degree, right? So if it's a first degree, a third degree, a fifth degree polynomial, then it must have at least one zero. Go ahead and highlight that. That's really important. It's got to have at least one zero. A polynomial function of even degree may or may not have a zero. So again, if your polynomial is a second degree, fourth degree, sixth degree polynomial, it could not have a zero. It just depends on the polynomial, and we'll look at some other stuff later on to help you figure out that. All right, so those are the first couple of things you guys need to know about these guys. Here's a couple more things real important that are about zeros. First is this. Recall that zeros occur at x-intercepts, right? So in order for it to be a zero, you have to cross the x-axis. What this means is the number of times the graph intersects the x-axis is equal to the number of real zeros, right? Every time you cross the x-axis, you're going to have a zero. There's one little caveat to this that we're going to spend a little bit of time talking about right now, and what it is actually not an x-intercept, but what we call a point of tangency, where the graph comes down and touches the x-axis, but doesn't cross it. So let me highlight it first, and then I'll show you exactly what I'm talking about. These points of tangency. Let me draw you a quick little picture to help you see this, and then we'll talk about it a little bit more. It'll make perfect sense when we get done talking about it. So I'm going to draw myself a quick little graph right here. Now on my graph, I'm just going to draw myself this nice little parabola. I'm going to put a couple of spots in here. This is going to be x equals -2. We'll call this one x equals +2. And here's what I want. I want a polynomial that just kind of looks like this. We'll just do one of these guys. Oh, beautiful. I love it. That is a gorgeous polynomial. Actually, let me do it in a slightly different color so we don't confuse my polynomial with my axes. All right, there's my polynomial in green. I should have done my axes in black. Let me do my axes in black. Sorry about that, guys. Here is a much better graph. There's x. This is f of x, right? Because I'm graphing my polynomial. In fact, you know what? Let's not call it f of x. I like this even better. Since it's a polynomial, we'll call it p of x. I know, fancy naming, real original, but whatever, that's what it is. All right, there's polynomial. Okay, and again, I apologize. Let me just trace this one more time real quick. I want you to make sure that you see that that touches, right? That comes down and touches the x-axis but doesn't cross. Really, really important. So here's what we've got. We've got my two types of zeros. We talked about when you cross the x-axis, which I do right there, and when you just come down and touch the x-axis. So two different kinds of x-intercepts, and we want to talk about both of them right now. If you have what we call an x-intercept, which is what I've got right here in yellow, right? That is an x-intercept. Here's what you have. This is where you have crossed the x-axis. What this does is that means then that this point, this value of x, which is -2, -2 is a real 0. Right? -2 represents a real 0 or root, right? Real 0 or root for this particular polynomial. Right? No big deal. We're used to that from the quadratic functions back in chapter 4. But this one right here, where you just come down and you touch the x-axis and then you go back the direction you came. You don't actually cross the x-axis. We actually call this a point of tangency, or when you're tangent to the x-axis. Let me throw that guy right there in blue, right? There it is, circled in blue. This is what we're going to call a tangent. When I'm tangent to the x-axis. And here's what's going on. What that means is this. What happens is when you come down and you touch the x-axis and then go back the direction you came from without crossing the x-axis, that root, that 0, is actually going to count as a double 0, which is exactly what I told you right up here in the part that we highlighted. The point of tangency is called a double 0. Again, you just have to remember that if you come down and touch the x-axis and then go back the direction you came without crossing, what that means for us on our graph, since that's at x equals +2, that means that 2 is a double real 0. That just means it counts twice, right? You count that 0 twice. So if I were to ask you for the zeros of this particular polynomial, you actually have 3 of them. You have x equals -2, which is where I cross the x-axis. You have x equals a +2, x equals a +2, but that's a double 0 because it's a point of tangency, so you need to count it twice, and you have a total of 3 zeros. In some books, guys, you will see this called multiplicity. That right there. When you wind up with a 0 being a 0 more than once because of a point of tangency to the x-axis, we call that multiplicity because this answer shows up twice. It's a double 0. So what I've got for you guys here then is just a real quick recap for you. You've got two things you got to watch out for. Do you cross the x-axis and get a real 0, or do you just come down and have a point of tangency where again you'll get a real 0, but it counts twice. It's actually a double 0. So let's show you a couple of these. What I've got here is I've got some even degree polynomials, and I just want to know how many real zeros do you have. We'll go ahead and do this in green. Well, you know that you have a real 0 anytime you cross the x-axis or you come up and touch the x-axis and have a point of tangency. This first one doesn't cross the x-axis at all. So how many zeros do you have? Well, you have 0 zeros. You don't have any because it doesn't ever cross the x-axis and there aren't any points of tangency. But since this is an even degree polynomial, guys, that is perfectly okay. Remember, I highlighted right up here, even degree polynomials may not have a real 0. So that's absolutely okay. Don't break any rules there. What about the next one? Well, I cross the x-axis once, twice, and then I have a point of tangency right there, which counts as a double 0. So actually, oh, I apologize. There's actually a typo here in this one. That is not 3 zeros. I apologize. I fat-fingered something. That is going to be 4 zeros. Because this guy right here counts as a double 0, so I have 1, 2, 3, 4 zeros. Come over here to the odd degree polynomials and we count our zeros. Let's see what we've got. I've got 1, 2, 3. I crossed the x-axis 3 times. 3 zeros. Holy cow, I'm sorry, I did it again. I must have maybe used this example problem for something else in previous, and that's why it's not right, or I've just fat-fingered something. I cross there, and then have a point of tangency right there, which counts as a double 0. So 1, 2, I have 3 zeros. 3 zeros for that one. So again, guys, you don't write no algebra required, right? I didn't have to do any algebra in order to figure this stuff out. I just know a couple of things about polynomials, even in odd degree polynomials, and then what it means if you cross the x-axis or just have a point of tangency to go ahead and figure out some stuff about real zeros. Guys, head on over to the next page of notes and we'll look at a few other things we can tell about the graphs of polynomials just by looking at them. I'll meet you there.